Hi, Stu Schwartz from MasterMathMentor.com. This is video AB Review 1. The topic is complex fractions and it covers the AB manual, page 269. Many students see complex fractions and completely freeze, having no idea how to deal with them. Let us learn once and for all how to work with them. Complex fractions are fractions within fractions, and we never leave answers with complex fractions in them. The simplest type of complex fraction is in the form of a fraction over a fraction. For example, A over B divided by C over D. We can rewrite that by inverting the denominator and writing this as A over B times D over C, and our answer is AD times BC. So if we have x to the negative 1 power over y to the negative 1 power, we can simply write that as y over x. But if we have 1 plus x to the negative 1 over 1 plus y to the negative 1, we cannot flip our denominator. We will write this as 1 plus 1 over x divided by 1 plus 1 over y. So when we have 2/3 over 5/6, there's two ways to deal with this. We can write this as 2/3 times 6/5 and get 12 over 15 and reduce this to 4/5. Or we can use the technique of multiplying both top and bottom by the LCD, the least common denominator. The least common denominator of 3 and 6 is 6. So we multiply our expression by 6 over 6, which is 1 and therefore allowable. And when we do that, we get wholesale cancellation, and our answer is also 4/5. 2 reads 1 plus 2/3 all over 1 plus 5/6. There are two methods of dealing with this. The first method is one that many teachers teach, and I do not recommend, but let's show it. We will work with both numerator and denominator, getting common denominators in each. So for the numerator, we will write 1 plus 2/3 as 3/3 plus 2/3. And for the denominator, we will write 1 plus 5/6 over as 6 over 6 plus 5 over 6. Adding up, we get 5/3 over 11/6. And now we can invert the denominator and multiply, getting 5/3 times 6/11. We get 30 over 33 and 10 over 11. However, the recommended method is to multiply every term by the LCD. The LCD of all the terms is 6. So we multiply every term by 6, and we get 6 plus 4 over 6 plus 5. The complex fractions immediately disappear, and we get our final answer in a much easier fashion, 10 over 11. On number 3, we have 3/4 plus 5/3 all over 2 minus 1/6. The LCD of all four terms is 12. So we will multiply the entire expression by 12 over 12. And with cancellation, we get 9 plus 20 over 24 minus 2. Final answer, 29 over 22. Number 4 reads 1 plus 1/2 x to the negative 1 all over 1 plus 1/3 x to the negative 1. So we will eliminate the negative exponents and write this as 1 plus 1 over 2x all over 1 plus 1 over 3x. The LCD of all four terms is 6x. So multiplying by 6x over 6x, we get 6x plus 3 all over 6x plus 2. In number 5, we have x minus 1 over 2x all over x squared plus 1 over 4x squared. The LCD of all four terms is 4x squared. So we will multiply the entire expression by 4x squared over 4x squared. And we get 4x to the third minus 2x over 4x to the fourth plus 1. We could factor out the numerator if we wish to, but it is not necessary. In number 6, we have 2/5 x to the 5/3 all over 5/3. The LCD of this expression is 15. So we will multiply every term by 15, and we end up getting 6x to the 5/3 all over 25. In number 7, we have x to the negative third plus x all over x to the negative second plus 1. We write these as complex fractions, 1 over x to the third plus x all over 1 over x squared plus 1. We then multiply out by the LCD, which is x to the third over x to the third, and we end up getting 1 plus x to the fourth over x plus x to the third. In number 8, we have 1/2 times 2x plus 5 to the negative 2/3 all over negative 2/3. So since we have a term over a term, we can bring the expression with to the negative 2/3 downstairs. And we can write this as 1/2 over negative 2/3 times 2x plus 5 raised to the 2/3 power. So we then multiply out by 6 over 6, and we end up getting negative 3 over 4 times the quantity 2x plus 5 to the 2/3 power. Number 9 is a type of problem that you encounter in calculus all the time. X minus 1 to the 1/2 minus x times x minus 1 to the negative 1/2 all over 2, all divided by x minus 1. Since we have terms upstairs, we will have to write the x minus 1 to the negative 1/2 as x minus 1 to the 1/2 in the denominator of that term. So we end up with x minus 1 to the 1/2 minus x over 2, quantity x minus 1 to the 1/2, all over x minus 1. The expression that will clear out the terms is x minus 1 to the 1/2, and we will also throw in a 2. So we multiply by 2, quantity x minus 1 to the 1/2 over itself, and we end up getting 2 times the quantity x minus 1 minus x all over 2 x minus 1 to the 3/2 power. Final answer is x minus 2 all over 2 quantity x minus 1 to the 3/2 power. Once you start working with complex fractions and getting used to them, you will find that they are easy to deal with and eliminate.